right, so section 7.1 talks about trigonometric identities. You look at the identities in this box, do they look new? No, because we've already talked about them before. Okay, we put them here again because now you're going to be seeing and actually using these whenever we are simplifying trigonometric expressions and proving trigonometric identities. Okay, we've already done an example where we've rewritten an expression in terms of and made it an algebraic expression. You'll see things like that again here in this semester, in this section. Okay, so you have your reciprocal identities, you have your Pythagorean identities, your even odd identities. Sine is what kind of function, even or odd? Odd, good. Tangent is also odd. And then cosine is? Even, good. You have cofunction identities here. Cofunction identities. You have sine of pi halves minus x is equal to cosine of x. Cosine of pi halves minus x is equal to sine of x. Tangent of pi halves minus x is equal to cotangent of x. Cotangent of pi halves minus x equals tangent of x. Secant of pi halves minus x is equal to cosecant of x. And cosecant of pi halves minus x equals secant of x. Okay? So now we're going to use these identities that we have here in our examples whenever we are simplifying trigonometric expressions and proving identities. Okay? All right, so let's look at example 1. Example 1, we have to simplify the trigonometric expressions. Part A, we want to write the trigonometric expression in terms of sine and cosine and then simplify. Okay, those are the instructions. So here we have tangent of theta times cosecant of theta. So it says write in terms of sine and cosine and then simplify. Tangent of theta is what? Sine of theta over cosine of theta, good. And cosecant of theta is what?
1 over sine of theta.
Good, 1 over sine of theta. And now what can we do?
Cross multiply?
Do we need to no, we don't cross multiply here. You cross multiply whenever you have an expression equal to another expression. Here you don't need to do that because you're multiplying this rational expression times this rational expression. Or what can you do before you multiply the numerator times the numerator and the denominator times the denominator? Do what? Yes, they cancel out. Good. So you cancel out sine thetas. And this is just equal to what? No, not just cosine theta. 1 over cosine theta, you got it. And 1 over cosine theta is what? Good, secant of theta. So we rewrote that trigonometric expression in terms of sine and cosine and we simplified it. That's it. What questions do you have? Yes?
It kind of relates to the test, but also this.
I won't answer on the test questions, but you can ask me whatever question you have. Just ask.
It's a format you said that we would have to like type in an answer potentially. Is that going to be on this test or just the final? Because you said
this test is a possibility as well. This test you might have a question where you have to verify an identity. If you have something like this, you're going to have to verify it by showing your work or writing something in. This type of question typically isn't set up as multiple choice, not unless I provide an outline for the proof and ask you to choose the correct one. Okay? You may have a question or so where you may have to justify your reasoning. And if you have to justify your reasoning, then you take a picture of you write your work, take a picture of it and scan it in.
Okay. Thank you.
You're welcome. Or you won't have to scan it in, take a picture of it and upload it. What other questions do you have? Okay. In part B, we have to simplify the trigonometric expression. We have to simplify the trigonometric expression. Here, it doesn't say put it in terms of sine and cosine first and then simplify. So we can just use whatever we know to simplify. Okay? So we have sine of t divided by 1 minus cosine of t minus cosecant of t. And this problem is a little bit different. This one is a little bit different. So let's note a couple of things first. So note that since sine squared t equals 1 minus what? Good. Cosine squared t. Notice that 1 minus cosine squared t you can factor as 1 minus cosine t times what? Times what? No. You want 1 minus cosine squared t. 1 plus cosine t. Good. 1 plus cosine of t. Now, we look back up in our expression that we have, and notice you have a 1 minus cosine t in your denominator. So this is nice that we have this equality here, because we can actually solve for 1 minus cosine t. Are you with me? So we can solve for 1 minus cosine t, right? So that means sine squared of t divided by 1 plus cosine of t is equal to 1 minus cosine of t. Yes?
Does that apply to everything, like any problem, like sine squared t over 1 plus cosine?
Yes, because that's just using the identity.
Okay.
And there's a specific reason why we're using this here, or the reason why we're solving for 1 minus cosine of t. So your question, is that true all the time? Yes, this is true all the time, because all we did was take that Pythagorean identity and we manipulated it algebraically. So yes. And the reason we wanted to do this, because notice that now we isolated 1 minus cosine t. So now we can take this and substitute it in for 1 minus cosine of t here. Okay? So now sine of t divided by 1 minus cosine of t minus cosecant of t is equal to sine of t divided by sine squared t over 1 plus cosine of t, because remember this is equal to 1 minus cosine of t. And now we subtract cosecant of t, which is just 1 over sine t. But then we have to simplify this expression here. It looks a little complicated, but we can rewrite it. So this is the same thing as sine of t. Dividing by that is the same thing as multiplying by what? The reciprocal of it. Good. So you have 1 plus cosine of t divided by sine squared t. All of that minus 1 over sine t. Now, notice that we have a sine t here, and we have sine squared t, which means this is sine of t times sine of t. So one of those cancels out. So that cancels out with that one and just leaves you 1. So on the side, remember that sine squared t is equal to sine of t times sine of t, right? So one of those cancels out. Does that make sense?
Yeah.
Okay. Now this looks better because now we have that this is equal to 1 plus cosine of t all over sine of t minus 1 over sine of t. Well, this is good now because they have the same denominator, which means we can do what with the numerators? Subtract them. Subtract your numerators. What do you have? Cosine of t, and that will be all of that over what?
Sine of t.
Good. And what's cosine of t over sine of t? What did you say? Cotangent of t. Good. So we simplified that expression. Simplifying that expression yields cotangent of t. What questions do you have? Online, what questions do you have?
I don't have any right now.
Okay. All right. You need a minute writing this? See head shaking no. Yes, you do?
Yeah.
Okay. All right. So now what we've done, we took an expression and we simplified it. Now what we're going to do is prove trigonometric identities. So what are the guidelines here? You will have a trigonometric expression on the left equal to a trigonometric expression on the right, and you want to prove that those two identities are this, or prove that this identity is true. Okay? Now, the way we do that, we start with either the left-hand side and prove that's equal to the right-hand side, or you can start with the right-hand side and prove that's equal to the left-hand side. Okay? Now, let's talk about the guidelines. You start with one side. So you pick one side of the equation and write it down. Your goal is to transform it into the other side. It's usually easier to start with the more complicated side, right? Because when you start with the more complicated side, you can use your trigonometric identities, substitute those in, and then sometimes you may get some cancellations, or you might have to multiply a function by 1 in a nice way, and you'll have some things that happen algebraically. 2, use your known identities. I got ahead of myself and said that already. Use algebra and the identities you know to change the side you started with. Bring fractional expressions to a common denominator. Factor. And use the fundamental identities to simplify expressions. 3, convert to sines and cosines. So if you get stuck, you may find it helpful to rewrite all of your functions in terms of sine and cosine, because then it'll be something that you're familiar with and you can see cancellations better. So always revert to that if you get stuck. Okay? So let's look at an example. We're going to prove that this identity is true. We're going to verify algebraically that the equation is an identity. So sine of x plus cosine of x divided by secant of x plus cosecant of x equals sine of x times cosine of x. Which side looks more complicated, the left-hand side or the right-hand side? The left-hand side. So let's start with that one because it says it's usually easier to start with the more complicated side. Okay? So we're going to take that left-hand side then, and we're going to write that down. You always start with that. You always start with writing down what you're starting with. Does that make sense?
Yeah.
You always start by writing down what you're starting with. Okay? Now, sine of x plus cosine of x is already in terms of sine and cosine. There's nothing we can do with that. So we'll leave it alone. We're going to say that's equal to sine of x plus cosine of x. But when we look at our denominator, we see secant of x plus cosecant of x. So now we're in step 2 where we're using our known identities. What can we use in our denominator? Go ahead.
You can convert secant x into 1 over cosine x.
Good. So we have secant of x is 1 over cosine of x.
And then cosecant of
So plus 1 over sine x. Good. Okay, so far so good. Now you can simplify your denominator before we move on. Find a common denominator here and simplify this. So remember, if you have 1 over cosine x plus 1 over sine x, that's the same thing as sine x plus cosine x divided by what?
1.
No. So let's enlarge that part. So I'm asking you, if you have 1 over cosine of x plus 1 over sine of x, what's that equal to? Don't go backwards. Don't tell me it's secant of x plus cosecant of x. What would this be with a common denominator here?
The 1 over cosine x by sine of x.
By what?
By sine of x.
Not just sine of x.
Sine of x over sine of x.
Multiply by sine of x over sine of x. Good. And then multiply 1 over sine x by?
Cosine of x over cosine of x.
Good. And then simplifying, what do we get?
Sine of x plus cosine of x over cosine of x sine of x.
Good. That's exactly what we get. So now we're going to take that and put that in our denominator. See, you're going to have to remember your algebraic techniques. I'm telling you, you're going to have to use them. I promise you that. So this is equal to, write down your numerator. It was sine x plus cosine x. And now we're replacing our denominator with the work we did on the side. So sine x plus cosine x divided by cosine x sine x. But we're dividing by that rational expression. So dividing by that is the same thing as multiplying by what?
Reciprocal.
Good. So you have sine x plus cosine x times cosine x sine x divided by what?
Sine of x plus cosine of x.
Good. Now what happens?
Sine of x plus cosine of x cancels.
Right. They cancel out, right? And we're left with what? Cosine of x sine of x, which is the same thing as sine x cosine x, just in a different order. So just to be consistent, we can write it as sine x cosine x. So we took this complicated left-hand side, used our identities, did some cancellation, and we got that is equal to sine x cosine x. So we just verified that this equation is indeed an identity. What questions do you have? What questions do you have? Need a minute? See heads nodding yes. Example, what are our guidelines? Let's look at it. Our guideline says bring fractional expressions to a common denominator, factor, and use the fundamental identities. We use the fundamental identities, but let's see if we can factor it. Can you factor? The next example, we have sine x minus 1 divided by sine x plus 1 equals negative cosine squared x divided by sine x plus 1 quantity squared. This minus 1 is not on the inside of the x. So you can think of sine x as one thing minus 1. And so what we're going to do here, we're going to end up starting with the left-hand side. And the reason we're going to start with the left-hand side here is because we look at the right-hand side and we know an identity that involves negative cosine squared x. We also look at this denominator and think like, wait a minute, we don't know sine x plus 1 quantity squared. But if that's what we want to end up with in our denominator, what can we multiply by over here? Good, multiply by sine x plus 1. So we're going to first we have to write down what we're starting with. We're starting with sine x minus 1 divided by sine x plus 1. So that's what we're starting with, right? So we write that down. That's going to be equal to sine x minus 1 over sine x plus 1. But we said we're going to multiply by sine x plus 1 because we see this sine x plus 1 quantity squared in the denominator. So that gives us a clue to multiply by that. But we can't change the problem, so we have to multiply by that in the form of 1. So notice that we're just multiplying by 1 in the form of sine x plus 1 divided by sine x plus 1. Does that make sense so far? What questions do you have? Okay, so we multiply it. Multiplying your numerators. Notice that you have sine x minus 1 here, sine x plus 1 here. So what's going to happen to the middle term, or the outer term, or the inner term? When you use the FOIL method to multiply the numerator times the numerator, what happens to your outer term and your inner term? They cancel. Good. They cancel. So you'll end up with sine x times sine x, which is what? Sine x squared. Do you prefer to see it like sine x quantity squared or sine squared x? Sine squared x. Okay, they're the same exact thing. Okay, so that's sine squared x it's just a matter of preference. And what else do you have?
The denominator going to be sine squared.
No, what's the rest of your numerator? Good, minus 1. Because your outer and inner term, you would get sine plus sine x minus sine x, so they cancel out, and then multiply the negative 1 times the positive 1, you get minus 1. And then your denominator is just the quantity sine x plus 1 squared. Right? We see we don't need to expand that or multiply it because you look at your right hand side up here and it didn't have it expanded. Now, you have a Pythagorean identity involving sine squared and cosine squared. What is it? What's the identity?
Sine squared x plus cosine squared x equals 1.
You know sine squared x plus cosine squared x equals 1. So that means sine squared x minus 1 equals what? Negative cosine squared x, which is exactly what our numerator is. Negative cosine squared x divided by the quantity sine x plus 1 squared. So we just proved that this equation is an identity. We started with the left-hand side. We multiplied by 1 in this form. And then we simplified using algebraic or using a trigonometric identity, and we got what we wanted. What questions do you have? Okay. Part C. Cosine of theta divided by 1 minus sine of theta equals secant of theta plus tangent of theta. We want to prove that this equation is an identity. Which side looks more complicated?
The right side.
The right side? Okay, you wanna start there?
Yes.
Okay, so let's start with the right hand side. And you want to somehow prove, you wanna start with this side, you said, and you wanna prove this is this side. So, what do we write down first?
Secant squared, or secant theta plus tan theta.
Good, because that's what we're starting with. So secant theta plus tangent theta. What's that equal to?
Cosine theta over 1 minus sine theta.
No. Secant theta is not cosine theta over 1.
Oh, sorry, I misunderstood what you said. That's 1 over cosine theta.
Good. Secant of theta is 1 over cosine of theta. Plus what?
Sine over cosine theta.
Sine of theta over cosine of theta. Now what do you think we should do?
Just add, because we have the same denominator.
Okay. So what do we get?
Sine theta over cosine theta.
No. What happened to the 1?
I'm sorry, 1 plus sine theta.
Okay. So
Over
1 plus sine of theta over what?
just cosine theta.
Over cosine of theta. Okay. Now what?
Use the Pythagorean identity to find what 1 plus sine theta is equal to.
Which Pythagorean identity would you use?
Sine squared of theta plus tan, or cosine squared of theta equals 1.
But that only gives you, so you're saying you have sine squared theta plus cosine squared theta equals 1.
That wouldn't work.
And you were trying to get 1 plus sine theta,
Yeah.
but you said that wouldn't work now.
That would give you 1 minus sine of theta, sine squared theta.
Mm-hmm. Right. And then you get cosine squared theta equals that. So we don't want to use that. What else can we do?
Could we, is there a way to write cosine theta in terms of sine theta?
Can we do that? You said, can we write cosine theta in terms of sine theta? Is that possible?
I don't think so.
No, it's not. No, we can't. So you got to a point where we're stuck, right? So now you have to think about your identities. And in thinking about your identities, you have to think about how they show up, like a squared here. So we don't see anything squared down here. So that kind of implies that maybe we should multiply by something where we can square it, where it will end up being squared. So let's multiply by cosine of theta. So I'm another step, so I'm going to use a different color. So let's multiply by cosine of theta over cosine of theta. Let's see where that goes. Let's see where that leads us. So that's going to be equal to cosine of theta times the quantity 1 plus sine of theta over, what's cosine of theta times cosine of theta? Cosine squared theta. Good. Cosine squared theta. Oh, but wait a second. You know that with this identity here, you have a cosine squared theta. So what can we do here with this identity?
Solve for cosine squared theta.
Good, solve for cosine squared theta. So we had to pause for a second, think of a way out. The way out was trying to incorporate an identity, so we had to multiply by 1 in the form of cosine theta over cosine theta. Okay? So now we solve this identity for cosine squared theta. We get that's equal to 1. What's the rest?
1 minus sine squared theta.
Good, 1 minus sine squared theta. Substitute that in for cosine squared theta. So that gives us cosine theta times the quantity 1 plus sine of theta all over 1 minus sine squared theta. But 1 minus sine squared theta, you can do what with that? Look at what you want to end up with. We want to end up with cosine of theta divided by 1 minus sine of theta. Yes?
You can just cross out one of the signs.
No, that's illegal. You cannot cancel out a sine of theta. Why? Because this is not a sine theta on the outside here, and this doesn't have a sine theta multiplied by all of that. In order to cancel out, it has to be multiplication there. So we cannot do that. What can you do with this 1 minus sine squared theta?
You can take the square root.
No, taking the square root leave you with plus or minus. But if you don't want to take the square root, what can you think of doing? Let's go back to our guidelines. Yes?
Could you, I don't think that, yeah, that would.
Can you what?
I was gonna say, could you write that, can you somehow rewrite that as, sine squared theta plus cosine squared theta, is that what I'm doing?
No, we just use that identity to solve for cosine squared theta, and then we substituted that in. So you don't want to work backwards.
Okay.
Let's go back here. 1 minus sine squared theta? If so, how?
1 minus sine of theta times 1 plus sine of theta.
Very good. So this is equal to cosine of theta times 1 plus sine of theta divided by the quantity 1 plus sine of theta times the quantity 1 minus sine of theta. And what gave it a way to factor was looking at the denominator of that left-hand side. You have 1 minus sine of theta. You have a difference of squares here. So you can always factor a difference of squares like this. Okay? Now, what happens?
The 1 cancel.
Which will cancel?
The 1 plus sine squared,
Good. The 1 plus sine, wait a minute, the 1 plus what?
sine theta, sorry.
1 plus sine of theta is cancel. And we're left with what? The answer, or the left-hand side, which is what we wanted. So that's equal to cosine theta divided by 1 minus sine of theta. So you started with the right-hand side, and you got that was equal to the left-hand side. Or the right-hand side, and we got that's equal to the left-hand side. Okay? Now, in this problem, you could have made your life easier by starting with the left-hand side. Because you could have multiplied by 1 in the form of 1 plus cosine theta over, 1 plus sine of theta divided by 1 plus sine of theta, and you would have been able to work backwards like that. But as you saw, it doesn't matter whether you start with the right-hand side or the left-hand side as long as you prove that the equation is an identity. Does that make sense?
Yeah.
What questions do you have about this? All right, so that's section 7.1. That's simplifying trigonometric expressions and proving identities. proving trigonometric identities, okay?